look at another limiting reactant problem involving mass. This one has a little different twist to it. I think you'll like it. The first time I read through this scenario, I just want the balanced equation. The hydrochloric acid in your stomach can be neutralized by taking an antacid tablet containing aluminum hydroxide. Antacids are bases. Stomach acid really is hydrochloric acid. And so I think we mentioned earlier that bases often contain hydroxide. So the aluminum hydroxide is a base that can neutralize the acid in your stomach. Okay, that's all I care about right away. Those are my two reactants. The stomach acid is the HCl. HCl. Reacting with the antacid tablet containing aluminum hydroxide. Plus 3 minus 1. It's only 3 hydroxides. Neutralize just means to react completely together, as completely as possible. And so this is essentially a double replacement. Hydrogen and chlorine are each plus 1 minus 1. So we could switch the hydrogen and the aluminum. I'd get aluminum with chlorine plus 3 minus 1. I need 3 chlorines. And then our other product, oh, this is interesting. Hydrogen with hydroxide. Plus 1 minus 1. I think we mentioned that hydrogen hydroxide a while ago. It's really just a fancy way of writing water. It's always one of the products in a neutralization. The last topic of the year is acid-base chemistry. The acid always contains hydrogen and the base hydroxide. So when they are neutralized, you'll usually end up with water as a product. Okay, so let's balance this puppy. Well, I know right away I'm going to need 3 chlorines, 3 hydrogen, and 3 hydroxide. And what do you know? Here's the hydrogen and the hydroxide. 1 aluminum, done. So I need the balanced equation. I need that ratio, the ratio of moles. So now as I read through the rest of this, I see that I'm given grams. If 24.5 grams of hydrochloric acid were secreted by the stomach, and the antacid tablet contains 12 grams of aluminum hydroxide, will just 1 tablet be enough to neutralize the stomach acid? So this is from the tablet, the antacid. Antiacid, it's the base, and then this is the acid. The HCl is the acid. So eventually I want to compare them using that 1 to 3, 3 to 1 ratio in the balanced equation. But it is not a ratio of grams. So whenever you do stoichiometry, if given grams, we need to get them both in moles. Aluminum hydroxide. So here's what I have, and it's an easy switch. We did this a while back, just switching from grams to moles. So there are no skills this third quarter that you can completely ignore or shove under the rug. We're still doing mole calculations. Good thing they're easy, right? HCl, I'll add it up on my periodic table. 36.46. So all we have to do is divide. So with 3 sig figs, 0.672 moles of HCl. And then we'll set up the other reactant. Cancel grams, we want moles. The periodic table tells me the mass of 1 mole. We just need to add it up. So we have 1 aluminum, 3 oxygen, and 3 times hydrogen. 78.01 grams. So about 0.154 moles of aluminum hydroxide. That's an L, aluminum. Now you really have to be careful with all of your units. There's a lot of numbers going on here. And And sometimes people that complain that they don't understand anything, I look at their work and I say, I don't know what you're doing either. If you don't have these numbers labeled, I can't help you. Is this 0.672 moles of something? Moles of what? Is it grams? I don't know. So you have to be real conscious about putting in units. Okay, cool. So now that I have these in moles, I want to figure out which is the limiting reactant and which is in excess. If we were just given one reactant, we can go ahead and do the stoichiometry right away. That's kind of what happened early in the study guide. We had one numerical value, and we just used that one number to set up our stoichiometry. But now we have two amounts given. We're given the amount of each reactant. And I need to know, is this a stoichiometric 3-to-1 ratio? And if not, which of those reactants will run out first? That's the one that dictates this reaction. When the limiting reactant runs out, the reaction's going to stop. And I won't make any product. I won't use any more reactant. So you have a few options here. You could pick one of the reactants, and it honestly doesn't matter which you pick. You could pick either. I don't know, last time I think I picked the first one. There, maybe let's just pick the second one. Let's say I pick the aluminum hydroxide. It really does not matter which you choose. We set up a little mole-mole conversion. We'll cancel moles of the one we picked. And we'll switch it to moles of the opposite reactant. We'll plug in the ratio from the balanced equation, 3-to-1. Moles of aluminum hydroxide would cancel, and so we'll multiply by 3. 0.462 moles of HCl. And again, what do these numbers mean? You have to put units in so you know what you have and what you're looking for. That's why science is better than math. These numbers mean something, right? I trust you can all do the math. You can multiply across, but then what does this number mean? Well, this is the amount of hydrochloric acid I would need to completely react the aluminum hydroxide. These amounts are what we really have. So we just make a comparison. I need 0.462. Oh gosh, I have more than that. I have 0.67 something. I have extra. So the HCl is my excess reactant. Which then by process of elimination, the aluminum hydroxide is my limiting reactant. Well, this answers the first part of the question above. Is one tablet enough to neutralize the stomach acid? No. Because the acid is still the excess reactant. No, it's not. So then, let's determine how much of the acid can be neutralized. So we start all calculations with the limiting reactant. You can go back to it in moles, 0.154 moles of your limiting reactant. Since it's in moles already, we can cancel moles of the limiting reactant, aluminum hydroxide. And this time, instead of switching it to a product, they want to know how much acid can be neutralized. So plug in the ratio, 3-to-1, done. And now if they ask how many grams of HCl can be neutralized, we'll just tack on one more. We'll cancel moles and put it back in grams. The periodic table gives me the mass of 1 mole, and in fact we actually already calculated it. It's up in here, 36.46 grams. And then we can plug this all in. Moles and moles are out. So multiply across, and we'd be looking at 16.8 grams. That's the amount neutralized the amount that gets reacted. Whoa, that doesn't say neutralized. Neutralized. Here we go. Well, that doesn't either. Good Lord. Neutralized. Which now, that actually kind of answers this next question. How many grams of the excess are consumed? 16.8. And then for the final question, all we have to do is subtract. Originally, we had 24.5 grams, but we're only going to react 16.8 grams. So then we subtract to get the amount excess, about 17.7 grams excess, or left over. So the whole neutralizing thing just means that they're completely reacting together. But we did have about 16.8 grams consumed, and so the rest of this original amount of acid is just left unreacted.